Hello, I'm Kutalmış and he is my teammate Ezdin. We are students in Computer Engineering Department at the Faculty of Engineering in Marmara University. The title of our project is Using Hierarchies in Reinforcement Learning Framework with Non-Stationary Environments.
In our engineering project, we have focused on two major challenges of reinforcement learning, which are the curse of dimensionality and learning in non-stationary environments.
The first challenge we have focused on is the curse of dimensionality. When the dimensionality increases, the volume of the state space increases so fast that the available data becomes sparse. This makes reinforcement learning infeasible when the state space is too large or continuous. How do we apply reinforcement learning in such environments? The idea is that we can divide the problem into independently solvable tasks, solve each of them, and combine their solutions to form a solution to the main problem. But how do we do that? By defining and using options together with actions. As it can be seen here, using options to pass from one hell to another decreases the number of decisions we have to make in order to reach the goal state.
Constructing options while the learning takes place is not a trivial task. So, we have designed a subsystem that runs parallel with the learning process and tracks the partial model to get the key elements for autonomous option construction. In order to define an option, we need a subgoal and initiation set. We can detect subgoals by using between centrality, which is a famous graph property. States with higher between centrality values are the regions where the density of the shortest paths get higher. These states can be thought as bottleneck on the graph. An initiation set is the set of states that an option can be selected. Our subsystem uses a ratio of number of shortest paths in order to construct initiation sets autonomously.
The second challenge we have worked on is about applying reinforcement learning in non-stationary environments. Generally, in reinforcement learning, environments are assumed to be stationary, which is an optimistic assumption since most of the real-world problems are not stationary. We have developed the SCD algorithm for detecting change points in non-stationary sequences. A non-stationary sequence is a combination of stationary segments, which are also called as regimes. Here it can be seen that the non-stationary sequence is composed of three regimes. The regime switching points are detected by tracking the Markov dependencies of the sequence. The drastic changes on the probability curves indicate change points. Results of our experiments showed that SCD algorithm is robust to noise up to around 30% noise rates. We have also used SCD on industrial sensor information for detecting anomalies in a dynamic production system.
Changes in non-stationary environment can be detected by tracking the action sequence by using SCD algorithm. We can connect the learning principle of reinforcement learning with the detection approach of SCD. In the learning process, an RL agent learns the environment by performing actions and getting reward from the environment. The main objective of the agent is to find an optimal path from the start state to the goal state. After a while, the agent starts to perform similar sequences of actions in each episode until the environment changes. Action sequence of each stationary behavior of the environment is considered as stationary regime, because each stationary behavior has a significant action sequence. Based on this implication, we detect changes on the environment by using SCD algorithm. Here is a result of small experiment on non-stationary environment with two stationary behaviors. The sudden change of probabilities indicate the switching point.
Here is the result of an experiment we conducted on a non-stationary environment which is composed of three regimes. The SCD output includes two peaks that are located on the regime switching points. It is possible to relate the dissimilarity between regimes with the height of the peak on switching points. Thanks for watching.